5 places science still can't explain. Our world, a planet we have mapped, measured, and explored for centuries, still holds pockets of profound mystery. We believe we understand the fundamental laws that govern it, the flow of water, the behavior of light, the very geology beneath our feet. Yet there are corners of the Earth where these laws seem to bend, where the expected gives way to the inexplicable. These are not myth or folklore, but tangible locations that challenge scientific certainty. They stand as silent monuments to nature's power to surprise. Riddles etched into the planet, resisting our tools and brightest minds. They invite curiosity and force us to question what we think we know. Join me as we journey to 5 remarkable locations where the rulebook of science is being rewritten. In the northern reaches of Minnesota, along the rugged shores of Lake Superior, the Brule River flows on its inexorable journey to the Great Lake. Here, within Judge C.R. Magny State Park, it encounters a peculiar geological formation, an outcrop of rhyolite, a volcanic rock harder than the surrounding landscape. This encounter creates a dramatic waterfall, a powerful display of natural force. But it is what happens next that has perplexed scientists and visitors for generations. The river, in its powerful descent, splits into 2 distinct cascades. One continues its conventional path, plunging down the cliff face and flowing onwards. The other, however, takes a far more mysterious route. This second stream pours into a deep, churning pothole in the rock, known ominously as the Devil's Kettle. It is a cauldron of roaring, turbulent water, a vortex that seems to swallow the river whole. From this point, the water simply vanishes. One would assume it re-emerges somewhere downstream, perhaps feeding back into the Brule River itself, or finding a new path to Lake Superior. But this logical assumption has, so far, proven impossible to verify. For decades, researchers have attempted to solve this hydrological puzzle. They have employed methods both simple and sophisticated, hoping to chart the water's subterranean course. Large, brightly colored objects, such as ping-pong balls, have been dropped into the kettle with observers posted downstream, waiting for them to reappear. They never have. More advanced scientific techniques have been deployed, including the use of fluorescent dyes and tracers, materials designed to be detectable in even the smallest concentrations. Scientists pour gallons of vibrant dye into the chasm, expecting it to color the river further down. Yet, the Brule remains stubbornly clear. The kettle holds its secret fast. Far to the north, nestled within a remote and sparsely populated valley in central Norway, a celestial drama unfolds with remarkable regularity. This is the Hessdalen Valley, a landscape of quiet, stark beauty. But when darkness falls, it becomes a stage for one of the most studied, least understood atmospheric phenomena on Earth. Here, unexplained lights appear in the sky. They dance, they hover, they flash. These are not meteors or satellites. The Hessdalen Lights show a bewildering variety of behaviors. Brilliant white orbs can hang motionless for over an hour. Yellow orbs can also linger. Red lights flash intermittently. Blue lights drift slowly through the valley. Sometimes they move at incredible speeds, darting across the sky. Sightings rose significantly in the early 1980s, turning this corner of Norway into a natural laboratory. A permanent research station was established in response. Project Hessdalen monitors the skies continuously. Cameras, spectrometers, magnetometers, radar. The data collected is extraordinary. Instruments show these are not optical illusions or misidentified aircraft. They are real, physical phenomena that emit energy and register across sensors. Radar tracks movement. Spectrometers analyze the light's composition. Yet a definitive explanation remains out of reach. Many hypotheses have been proposed. Ball lightning is one suggestion. Another is plasma generated by the valley's unique geology. The valley is rich in minerals like copper and zinc. Some propose the valley acts as a giant natural battery. River and rocks creating charge. Still, no single theory explains all the behaviors. The Hessdalen Lights continue their silent, luminous dance, a nightly spectacle that challenges atmospheric physics. Chapter 3. Off the southern coast of Western Australia lies the Recherche Archipelago, a chain of over 100 islands set against the deep blue of the Southern Ocean. On Middle Island, the largest in the group, nature has painted a scene so surreal it appears to be an illusion. Here, surrounded by a dense woodland of eucalyptus and a thin ribbon of white sand, lies Lake Hillier. What makes this lake utterly astonishing is its color, a vibrant, solid, bubblegum pink. From the air, it is a startling sight, a vivid pink oval, starkly contrasted with the emerald green of the forest and the sapphire blue of the nearby ocean. Unlike other pink lakes around the world, which can change color with fluctuations in temperature or light, Lake Hillier's rosy hue is permanent and unwavering. If you were to take a sample of the water in a container, it would retain its striking pink shade, suggesting the cause is not a trick of light or a reflection from the lake bed. The lake is also exceptionally saline, with salt concentrations comparable to those of the Dead Sea, creating a thick crust of salt around its edges. This extreme environment is inhospitable to most life, yet it is precisely here that the secret to the lake's color is thought to reside. The leading scientific hypothesis centers on the life that thrives in this hypersaline water. It is believed that the color is produced by a specific species of microalgae called Dunaliella salina. To protect itself from the intense salinity and sunlight, this organism produces carotenoids, the same orange and red pigments that give carrots and tomatoes their color. In the case of Dunaliella salina, the dominant pigment is beta-carotene, which in high concentrations can turn the water a deep pink or red. The presence of other microbes, such as halobacteria, which also produce red pigments, likely contributes to the lake's unique palette. However, this explanation, while widely accepted, is not entirely complete. Other lakes with the same microorganisms do not always display such a consistently intense and uniform pink. Scientists are still working to understand the precise combination of factors: the specific strains of algae and bacteria, the exact mineral composition of the salt, the temperature, and the amount of sunlight that come together to create the perfect, permanent pink of Lake Hillier. It remains a beautiful puzzle, a saline masterpiece whose full recipe is known only to nature itself. The lake glows, a testament to the extraordinary and often bizarre ways life adapts to extreme conditions. Chapter 4. In the heart of the vast Karakum Desert in Turkmenistan lies a spectacle of fire and fury, a landmark born from a human miscalculation that has evolved into a geological enigma. It is known locally as the Gates of Hell or the Door to Hell, and it is precisely that: a gaping, fiery crater, nearly 70 meters wide, that has been burning continuously for decades. During the day, it is a shimmering pit of intense heat. At night, its glow can be seen from miles away, a malevolent orange beacon in the empty desert, illuminating the sky with its unending inferno. The crater's origin story dates back to 1971. Soviet geologists, prospecting for natural gas, set up a drilling rig in this location. They had tapped into a massive underground cavern filled with methane. The ground beneath the rig, unable to support its weight, collapsed, swallowing the equipment and creating a deep sinkhole that began to vent enormous quantities of poisonous gas. Fearing the release of these noxious fumes into the atmosphere and their potential to spread to nearby towns, the geologists made a fateful decision. They decided to light it on fire. Their calculation was that the gas would burn off within a few weeks, neutralizing the threat. They could not have been more wrong. The fire they ignited has not gone out since. Chapter 5. In a remote corner of Death Valley National Park, California, lies a place of profound stillness and subtle magic. This is Racetrack Playa, a dry lake bed, almost perfectly flat and enclosed by steep mountains. The floor of the playa is a mosaic of dried mud polygons, cracked by the relentless sun. The landscape is stark, silent, and seemingly static. Yet, scattered across this barren expanse are large stones, some weighing hundreds of pounds. Behind them, etched into the dry mud, are long, distinct tracks. These are the sailing stones of Racetrack Playa, a century-old geological mystery. The tracks they leave are undeniable. Some are straight and long, others curve gracefully, and some show sharp, angular turns. Multiple stones often appear to move in parallel, their paths tracing similar patterns across the playa floor. The question that baffled scientists was elemental. What force could possibly be strong enough to move these heavy stones across a nearly flat surface, yet gentle enough to leave no other trace of its presence? For many years, the primary suspect was the wind. Death Valley is known for powerful gusts, and it was theorized that during rare rainstorms, a thin layer of slick mud could reduce friction enough for the wind to push the stones. However, calculations showed that wind speeds far exceeding any ever recorded in the area would be required to move the heaviest of the rocks. Other theories were proposed, involving thick sheets of ice, dust devils, or even seismic activity. But without direct observation, it was all speculation. The stones kept their secret, moving only when no one was watching. It was not until the winter of 2013 to 2014 that the riddle was finally and beautifully solved. A team of researchers using GPS-equipped rocks and time-lapse photography captured the phenomenon in action. The conditions have to be perfect. A rare rainfall must cover the playa with a shallow layer of water, deep enough to float a thin sheet of ice, but shallow enough to leave the stones exposed. As temperatures drop overnight, this water freezes into large, window pane-like sheets of ice around the rocks. When the sun rises, the ice begins to melt and break up into floating panels. Then, a light, steady wind, not a gale, is all that is needed. The wind pushes the vast sheets of ice, which in turn shove the rocks before them, carving the famous tracks into the soft mud below. The movement is slow, almost imperceptible, a gentle glide that explains the graceful, parallel tracks. The long-held secret of the sailing stones was a delicate dance between ice, water, wind, and sun. From the depths of the earth to the vastness of the night sky, our planet continues to present us with profound and beautiful challenges. The Devil's Kettle, the Hessdalen Lights, Lake Hillier, the Door to Hell, and the sailing stones of Racetrack Playa. Each is a testament to the intricate and often surprising systems that govern our world. While science has pulled back the curtain on some of these mysteries, others remain stubbornly enigmatic, their secrets held fast by nature. A final montage of all 5 locations. These places remind us nature still holds questions, and the search continues.